all of the problems during class. One of your teachers is going to go over probably half of the problems. And remember, there's 2 of each kind. So while you're in class, you might notice you need a little extra help with number 4. So maybe you do 4A and 4B. All right, anywho, number 1, we're going to use, this is a repeated standard that we're testing again. So everyone's going to try it again and everyone's going to get a new score. Make sure that this time when we're testing, we're doing a few things totally right. So we're distributing the 2x fully. And this becomes a 2x squared plus 18x. And then the negative 6x, same way. So we have a negative 6x squared and then a plus 18x. Last time I saw a few mistakes where people didn't distribute the x on the last term. They didn't distribute the negative on the last term. And then another very common mistake I saw, not very common, but the few people who made mistakes here, this is where it happened. You were trying to solve this, but it's not an equation. You're just smushing like terms together. So 2 minus 6, better known as negative 4x squared. So you're not doing opposites here. And then 18x smushed together with another 18x would be a plus 36x. Uh-oh, pen's not working. Come on, pen. It's supposed to say 36x. Here we go. There we go. So final answer, negative 4x squared plus 36x. Make sure you are not trying to solve this. This is just a simplifying question. So 1b is very similar. This time we're distributing a negative 4 here and here. And then you're going to distribute a negative 3x here and here. So we end up with, let's see, a negative 4x and then a minus 12. And then a minus 3x squared. And then what, a plus 15x on the last term? So it's really good to look at your old mistakes, even though sometimes they, hurt your heart a little because you're like, oh man, I never do that, and I did it. Well, here's your chance to rectify that. So we're going to combine our like terms. Remember, not opposites. We're just adding these together. Negative 4 plus 15 is a plus 11x. And there was no x squared terms. That's why I didn't bother combining it. And same thing with the constant. There's only one constant. So final answer, negative 3x squared plus 11x minus 12. Now, there's a little note here about what we call an error analysis question. We like to use these questions where we show you some other child's work, and it's going to be wrong every single time. And your job is to communicate with words what the child did wrong, and then you're going to go play teacher and you're going to go fix it for them. So those are kind of fun because, it's nice to point out other people's mistakes, right? I don't know. We're going to evaluate these next ones. Last time, some kids had some trouble with the calculator. They weren't using parentheses properly, or what kind of made me sad was some of you tried really nobly to do some math in your head, which is great. Normally. But on a test, maybe back it up by checking your mental work with your calculator. So if you plug in x equals negative 2, here and here, and y equals 3, here and here, this is great, but you either have to calculate the numerator and the denominator separately, or you need to make sure you put parentheses surrounding the numerator and denominator like I have shown here. So, I'm feeling up to a little mental math here. Let's see. This is a exponents first, so 4 times 6 is 24, minus 3, what is that, a 21? This is dangerous. I haven't even keyed this yet, guys. All right, negative 2. Now you do the squaring first, so this is a 9 times 3, so negative 2. Oh, man, come on, pen. Negative 2 minus 27 is negative 29. So I'm going to leave the answer like that. I would math enter that normally on a test to make sure it doesn't reduce, but I can tell that one will not reduce. So same thing here, we have 2 times a squared minus 5 times b divided by 6 times b plus 3 times the a being squared. So a is negative 2. Be careful because the a is actually over here on this part of the problem. And then b is 3 here and here. But again, if you're going to do this on your calculator, you need to calculate your numerator and denominator separately, or use parentheses around it like so. I'm going to try a little mental math here. Let's see, this is 4 times 2, which is 8 minus 15. So that's a negative 7 over, oh gosh, okay, 4 times 3 is 12. This is 18 plus 12, so that is 30. And you would normally try to reduce that, but that one does not reduce, so there's our answer. Okay, next section. This is another repeated section, but we've been working pretty hard at this during class this week, making sure that we clearly identify those variables. So very specific things here. We are trying to calculate the total cost of a granola purchase based off the weight of the cereal and the number of containers used. The customer is going to be charged $2.25 for each container, and then 75 cents per ounce, and then here's the formula. So specifically, what does T represent? Well, that you can pull right out of the questions. Total cost. The B, however, is multiplied by the 2.25. So remember, they're charged $2.25 for each container of cereal. So B must represent the number of containers that they used. Do not just write containers. We have to say the number of containers. Real specific. Okay, and my pen doesn't want to work again. Here we go. Come on, pen. Containers. There we go. And then W is what we're multiplying the 75 cents by. And that's because it's the weight of the granola. So you could write weight of granola, or you can say number of ounces. I'm going to go with weight of granola. In ounces, really specific. What was I writing? Granola, right? Okay, granola. And then you can even say in ounces. We talked the other day in class about never, ever, 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 ever putting the word per down here. So never write per, because that's an automatic wrong answer, so be careful. A makeup artist charges $45 for a sitting fee and then $15 per hour. So this formula is how we're going to charge the customer. C is the total charge, or total cost, or whatever you want to say. Ugh, this is not a good day for my pen, apparently. Whoops. Charge. That's not supposed to be there. And then H is multiplied by the 15. It's the number of hours. All right, 4A, this is that fun question where you get some free stuff, so you got to write out the formula. So we're saying you got to buy a commemorative mug for $8. We've seen this problem before. $5.50 for each bag of coffee, and then you get 2 bags free. So total cost must be represented by X. You have to buy the $8 mug, and then $5.50, but you can't say just like times C bags of coffee. You have to incorporate the 2 free bags, so you're going to say C, but then minus 2. You guys have been very good at those questions. I must say, this is the first year where I've given those questions, and you guys have just been killing it. All right, a gift shop advertises, and we've seen this question as well. 14 cents per letter, 6 letters are free, and you're going to buy the desk plate for $50. So total cost, you got to buy the desk plate, and then they're going to charge you 14 cents per letter. However, you can't just say times X, because you get 6 of them for free. And all they want you to do is set that one up. So we're good. All right, this next one, this is another repeated section. So we've seen this isolating section before. This is where we highlight or lock down the variable. So like in this case, we're locking down the B. You want to move any terms over. Got to do it in stages though, so we're going to subtract the Q. And we end up with 4 times B equals 7P minus Q. If it doesn't simplify, you just write down what you're reading. And then one more step, we're going to divide everything by a 4. Now, I'm running out of room and time, so normally I'd have you rewrite B equals 7P minus Q over 4. I'm going to skip that step, but I would like you to continue to do that on your test. All right, so same thing here with the next formula. We're solving for B again. Lock it down. This time, we're going to subtract the entire term AQ. And again, there's no simplifying here, so you just write down what you see. So 7B times T equals 5 minus A times Q. And then we're going to divide by, this time, 7 and T. You can do them at the same step, since it's the same operation. And then again, I would expect you guys to rewrite B equals this somewhere on your paper, because that's your final answer. Alright, excuse my nasty cold I have. I keep sniffling and coughing. Alright, solving for B again. A lot of things happening, but you have to start by multiplying by 4. You're going to do it to both sides of the equation, and this side is clearly going to be 4t. But a problem some of us had last time was we tried to distribute this 4 to the 5 and the 7. Well, these 4's are going to cancel, so there's nothing to distribute. So it's just 5b minus 7. So we're still going to solve for b. A few of you last time solved back for t again. That was kind of cute. Don't do that anymore. Alright, we're adding the 7. Oops, and I'm running out of room. Let me move this. Oh, jeez. Try again. Oh my gosh, be golly. Try again, try again. There we go. So 4t plus 7 equals 5b. And then last step is divide everybody by 5. And then once again, I expect you guys to write out b equals 4t plus 7 over 5. I feel kind of bad not writing them out now. I'm going to go back and write them all out. I think I might use this as my answer key, so I guess it should look pretty. Alright, b equals 5 minus aq over 7t. There we go. Alright, one more of those. Start by multiplying each side by 6. So over here the 6a, but over here the 6's cancel. So we're still trying to solve for t. We're going to subtract the 5 over. We'll start skipping that showing step. It's a little dangerous of me. I probably shouldn't at this point, but some of you guys have been so good at manipulating these equations that you have been skipping steps and doing a great job. What I need you to kind of think about, though, is if you have not been doing a great job while skipping steps, and maybe I've written you a note about, like, please show this step, you'll stop making that mistake. Try it my way. You know, I have a lot of experience. If I tell you to try something, just trust me. Alright, this next one, we're solving for b. There's b's all over the place. So first thing we have to do is collect the b's to one side. And then if you're not a b, get away. So we're going to add the 10 over here. So 7b is what we get over on this side because these are like terms. So 7b equals, these are gone, 9y plus 10 does not simplify. So you're just going to write 9y plus 10. And then one more step of dividing and we are good. Alright, b equals 9y plus 10 over 7. Very good, very good. Alright. Similarly here, we're going to subtract the 5a's to the left. And if you're not an a, you're going to move. So we're going to add the 6b. And I still like you guys putting the line down the equal sign. I think that really helps clean up your work a little bit and stops some goofy things from happening. So here we have a 2a. These b's are over here now, so this is 8 plus 6b. And then in this question, as far as the answer key goes, I don't care if you guys simplify these. You're just isolating for variables. So if you wrote 8 plus 6b over 2, that's great. But if you went further and divided both of these by 2, you could say 4 plus 3b. So I'm okay with that answer, or you could have just left it, like we said, 8 plus 6b all over 2. It is not your job in these questions to make them really pretty. Your job is just to isolate that one variable. Alright, these are the fun ones. You still have to get all the variables on the same side that you're trying to target. This time, I'm going to keep this a positive. I'm actually going to add the 4a over here to the right. And because 5 does not have an a, I ran out of room, I'm going to subtract the 5 over here to the left. So 6b minus 5, not going to simplify, so just write that down. But over here, the 5's are gone, but am plus 4a also does not simplify, so I'm just going to write that down. These are those factoring ones, so I'm trying to solve for a. All of them are grouped together, so now I'm going to factor them out of the group, and I'm left with a times m plus 4 equals 6b minus 5. And then our last step now is to divide. So the m plus 4 is going to get moved over through dividing the term, both sides. Final answer, a equals 6b minus 5 over m plus 4. I kind of like those questions. I don't know. Once you get the hang of them, they're kind of neat. They are very repetitive. I know some of you are bored. Don't worry, we'll get more exciting work next week. Alright, next term. Our next problem, we're trying to solve for the m term. So we're going to bring all the m's to one side. It really doesn't matter where. A lot of you guys like bringing the variable to the left. Unfortunately, there's a lot of variables here, which means the 9a has to move. So I'm going to subtract 9a. So, over here on the left, 5m minus tm. Nothing I can do there. Over here on the right, this is kind of gross. It's negative 9 minus 9a. If you reverse the order, I really don't care. But I do notice now I can factor out the m from the group, and if I take the m out of that group, I have 5 minus t. This is one of those questions where depending on your approach, you might have a totally different answer than me. And it's okay, because you are equivalent. Oh, now we're going to divide by 5 minus t. So somewhere I have to write my answer, huh? M equals negative 9 minus 9a over 5 minus t. If you brought m's to the right side, you're going to have a very different looking answer. All the signs are going to be different, basically. But that works for me. I'm sorry. I know that's really loud on the microphone. Alright, moving along. New stuff, finally. We're going to get new scores here. We're going to solve these systems by graphing. So remember, I don't graph so hot, but that's okay. We're just going to graph starting at your starting point, which is your y-intercept, down here at negative 2. And then your slope is up 5 over 4. So traveling up 1, 2, 3, 4, 5 over 1, 2, 3, 4 to the right. And just make a mental note that you have a positive slope, which we should have. So that's this line. And then this line starts at 4 on the y-axis. But the slope is negative 1 over 4. So you have to travel down 1 unit and then right 4 units to positive 4. So normally I'd... Ugh, ugly. And then... Yeah, ugly. But the point is where they crossed right here. That is our solution. So the location of that intersection point is 4, 3. And that's how you have to write your answer. All right, for number 2, we have 2 lines again. So 4x minus 4 starts at negative 4. And then the slope here is 4 over 1. So positive 4 up 1, 2, 3, 4 over right 1. 1, 2, 3, 4 over right 1. So I draw the blue line, and normally, this is a special line though. This is a horizontal line. So on the y-axis, go to 4 and draw a line through that point. If you can draw a line, which apparently I kind of can today. That's good. So this blue line, oh man, they do intersect, the red and the blue line, right here at the location, let's see, 2, 4. Make sure you're writing your ordered pair answers and make sure they're correctly written. Sometimes when you're graphing lines and doing ordered pairs on the same problem, it gets a little backwards and confused. So this line is not in my special form of graphing. I need to subtract the 3x over here. Sorry, the 3. So y equals 1/3 x plus, nope, minus 3. And then we got to solve for y over here as well. I'm going to start by subtracting the 4x over. So 3y equals, we subtracted the 4x plus 6. But now I got to go divide everybody by a 3. Ugh, gross. Alright, divide by 3, divide by 3, divide by 3. So this line becomes y equals negative 4/3 x plus 2. So, first line starts at negative 3. Has a slope of up 1, right 3 for 1/3. Yeah, whatever. Alright, we can also go down 1 and left 3. That's still positive. Pretend I graphed that line. Alright, this line starts at 2. And then has a slope of negative 4 over 3. So you're going to travel down 1, 2, 3, 4, but then right 1, 2, 3. So red line, blue line, they cross right here. They intersect at the solution of, my pen won't work. Here we go. That solution is 3, negative 2. Alright, next line. I'm going to add the 2 and add the 3x over, so this becomes 3x plus 2. And then this line, all I have to do is divide everything by negative 2. And then I'm going to kind of flip it around. So y equals, if you divide this and this by negative 2, you get positive 3x right here. Oh, special, minus 1. I'm not even going to bother graphing this. These are going to be parallel lines. Parallel lines do not intersect, so we're going to say no solution. But that was fun. Alright, we're going to keep going. This time we are solving by substitution. So you try to find a recipe for one of the variables, and this is awesome because it's already set up. It says y is negative 4x minus 5. So into the next equation, the other equation, you're going to replace your y with that formula. So right there. So this last line becomes negative 4x minus 4, but instead of y, we're using negative 4x minus 5. And now we simplify and solve. So you have to start by distributing this. Careful, it's a negative 4 into here. So we have negative 4x, and then what is that, a plus 16x plus 20? equals 20. Now don't panic. You're going to get a 0 on one side of this equation. So you have 12x equals 0 when you move terms around. Oh, come on, pen. Why? 12x equals 0. But 0 is still a number, guys. It is a solution. So x equals 0 is fine. Oh my goodness. It's like my tablet is working against me today. There's a ghost in my tablet, guys. All right, divide by 12, please. All right, x equals 0. Oh, goodness. Is this a sign that I should stop working? X equals 0. Try again. All right, x equals 0. And then you go up to this thing we boxed in. That's a recipe for y. So y is negative 4 times 0, which we just found, minus 5, which is 0 minus 5. So y must be negative 5. Final solution, written as an ordered pair, x, comma, y. Gosh, that was like a struggle. All right, here we go. This one, I have a recipe for y again. So I'm going to take that recipe into the other equation. Remember we talked about not plugging into your own equation. That's called a loop. Don't do that. So negative 12x plus 3, but we're not using y. We are using 4x plus 1. So negative 12x, that stays. Let's distribute the 3. So plus 12x plus 3. Oh, we're going to have a special solution. All right, here we go. X's are actually going to end up canceling. And we get 3 equals 8. Well, boys and girls, that's not true. So this is the case where you have no solution. Which is cool, because that means I'm done. All right, now these next two questions, they are not solved for any variable. So you kind of look through who has a really easy coefficient. Basically, you're looking for the number with the smallest positive coefficient. So like right here, this x would be perfect. So just subtract the 4y over. So this becomes x equals negative 4y minus 9. That's the recipe I'm going to use for x into the other equation. Now this gets a little tricky because there's a lot of negatives in this question. There's a negative first, and then instead of x, we're going to replace that with negative 4y minus 9. And then I'm going to keep going, so it says minus 4y equals 9. I have a feeling something weird happens here. Let's distribute the negative here and here. So you have positive 4y plus 9. And then a minus 4y equals 9. This is another case where the y's cancel. But this time you get 9 equals 9, which is true. 9 does equal 9. But that's not like a single solution, which means we have infinitely many solutions. Pen, please work. Solutions. So keep an eye out for those special solutions. This next question here, the variable with the easiest coefficient would be this guy right here. So if you could solve for that x, that would be perfect. Let's add the 2y over. So now, instead of x, we're going to use 2y, and we're going to use it right there. So 7, not x anymore, it's a 2y, plus 6y equals negative 20. So what is that, a 14y plus 6y? Oh, nice problems. And remember, we warned you, all of these should come out nice. So if you get a fraction, you got to go back and check it out. No fractions. All right, divide by 20, you get y is negative 1. And if I go back here and plug in y is negative 1, that gives me x equals negative 2. Oh my goodness, please, pen. X equals negative 2. So final solution, negative 2 comma negative 1. Alright, I'm going to try to do some fun work where I pause this video. I'm going to merge it with another video. So my next video, if you just keep going, you're going to hear the next few problems, I hope, unless I've screwed up. So apologies if I messed it up, but fingers crossed I did right. Alright, I hope this video picked up in the right spot. We're going to be solving this system by elimination. This is where you want one of the variables to knock out. So the first thing I look for is if I was just to add up x's and y's, they do not cancel. So we have to do a little bit of work. So now I have to decide would I like to eliminate the x's or the y's. And I look for easy numbers to work with, but I also look for opposite signs, because if the y's here already have opposite signs, then I don't have to worry about that. So what if I made this a 10y, a positive 10y, simply by multiplying by a 10? So my new system is 2x minus 10y equals 30, but the bottom equation is now, ooh, gross, 100x plus 10y equals negative 30. Oh, I was worried for a minute because I thought it was going to be a fraction, but I see what's going to happen now. We have 102x. These are gone. Equals 0. Remember, we talked about this on a previous question. Don't panic when a 0 shows up. A 0 is a number. So x equals 0. What I don't like about elimination method is now when I go back to find the y, I have to go back and do extra work. I'm going to choose whichever equation looks simpler. So I'm going to go with this bottom equation here and plug in 0 for x. So 10 times 0 plus y equals negative 3. This term is going to be nothing, so I'm just going to ignore it. And I see that y is negative 3. So my final answer written in ordered pair notation is 0, comma, negative 3. All right, similarly on number 10. Nothing's going to cancel right now when I add them up, but what if I wanted to knock out the x's? So this number right here has to be a positive 6x. So I'm going to need to multiply this equation by a negative 6 because I'm going to have to change his sign. So distributing that negative 6, that becomes 6x minus 36y equals, oh boy, let's see, positive 138. Hope I did that right. Let's find out. Bottom equation has not changed. It did not have to multiply by anything. Alright, so I see here the x's are canceling, so we did a good job with that. Negative 36 plus 12, let's see, that's a negative 24y equals, let's see, that comes out to 120. So we need to divide both sides by negative 24. Pretty sure that comes out nice. 5, doesn't, negative 5, doesn't it? I'm just going to double check. Yeah, negative 5. So y is negative 5. But now I have to go back to my favorite equation from the beginning and solve for x. So how about this top equation? So negative x plus 6 times negative 5, whoops, because we just found y, equals negative 23. So this is a negative 30, so I'm going to add 30 over here. I am really running out of room here, guys. Sorry. This becomes negative x equals 7, which means x equals negative 7. So we found x and y, and now I write my answer as an ordered pair. Sorry for the messy writing. So I know everyone loves elimination method because they're like, oh, it's so nice, but it's actually one of my least favorite methods. I think I mess up on them a lot, and that's my issue. Okay, here 11, we have really no good option for who I want to cancel. The good news is both variables already have opposite signs, so you just kind of make a decision. I'm going to go with y's. I want to eliminate the y's. And if you're ever having trouble with, man, what am I supposed to multiply by? You can always multiply them by each other's number. So like this top equation you can multiply by a 4, and this bottom equation by a 7, and you'll always get a common multiple to cancel out. So that's what I'm going to do. Sometimes it is the least common multiple, but who cares? You have calculators. So distributing a 4 to everybody here, you have a negative 24x plus 28y equals 20. Make sure it goes all the way through. And then this bottom equation is now a 56x plus minus 28y equals 140. So the y's cancel beautifully. Oh boy, what is that? 32x equals 160. I always feel like I'm messing these up when I get big numbers, but I think that comes out nice again to 5. So x equals 5. And I'm going to go back to my favorite equation from the beginning. I'm going to use this bottom equation. I don't know why. So 8 times 5, because 8 times x is 8 times 5. So that's 40 minus 4y equals 20. Subtract 40 over. So negative 4y equals negative 20. And y also happens to be 5. So this is an answer where they are the same number. That's just a coincidence, though, from the formula, or from the algebra. All right, next question is very similar. Both of them have opposite signs already, so I really don't care who you eliminate. I'm going to go with y's again. Why not? So I'm just going to multiply them by each other's number. So this top equation I'm going to multiply by a 3, and the bottom equation by a 5. So new system. Negative 6x plus 15y equals, oh boy, let's see, 84, right? Negative 84. And then, multiplying this bottom guy by 5, I get 35x minus 15y equals 55. And I'm a little too slow today to do these things in my head, but let's see. This is 19x. These are gone. and then equals, oh gosh, 80. I'm done doing mental math. I'm going to just go to my calculator. That's a 29. Oh no, that's because that's a 29 Abruzzo. See, I told you. Gosh, golly. All right, dividing by 29. I knew I did something wrong because my teacher told me that I'm not supposed to get fractions. All right, x equals 1. Going back to my favorite equation, I'm going to use this bottom one. If x equals 1, this is 7 times 1, so 7 minus 3y equals 11. So when you subtract 7 over, what? Abruzzo, you're doing something wrong again. Time out. I'm going to pause and see where I made a mistake. Guys, I'm so silly. This is a negative 29, so this is a negative 1, which makes this a negative 7. Ugh, lordy. Adding 7 to both sides, you have a negative 3y equals 18. This is better. Y is 6. Oh my goodness, I apologize. Negative 1 comma 6 is our final solution on that one. My bad. Alright, moving along. One more topic. We're going to be setting up variables and systems based on story problems. So we have Mickey and Donald are landscaping the garden. They lost their receipts. Mickey knows he bought 10 rose bushes and 1 ivy plant for a total of $33. And Donald bought 13 rose bushes and 9 ivy plants for a total of, I can't read that, I think it says $66. So both of their receipts are basically our two equations for our system, and we have to define variables and what they represent. So I'm going to use, x and y, why not, to represent the two unknown things, which is the selling price of each plant. So let's say x represents the selling price of a rose bush. And just like before, you have to be really specific. So don't just say rose bush, it has to be selling price of a rose bush. And then similarly here for y, it's the selling price of an ivy plant. Sorry for the messy writing. I'm late to lunch and I'm really hungry. Okay, so writing our system. 10 rose bushes plus 1 ivy plant equals 33. And then 13 rose bushes plus 9 ivy plants equals 66. Now for the test, all we're asking you to do is set it up and set up your variable allocation and then stop. So similarly here, I love this problem. The math teachers are selling grades as a fundraiser. You wish. Mrs. A sold 42 A's and 30 B's and raised $300. Mr. D raised $244 by selling 38 A's and 18 B's. Set up a system, tell me your variables. So wouldn't it make sense if we said A and B are the unknown things? Now be careful. It is the selling price for each grade. So don't just say A represents A's. It's the price of an A, and B is the price of a B. So Mrs. Abruzzo, this is A here, is selling 42 A's plus 30 B's for a total of 300. Then Mr. D is 38 A's plus 18 B's for, where are we at? 244. And again, you just got to set up your system, clearly define your variables. Just like on that other section, if it's not clear and very specific, you're not going to get the score that you want, because that's going to